Welcome to a new test and teardown video. This time it's a Philips EL6415. It's an audio amplifier mixer from 1961. It is really amazing. We got 4 input channels and they're all mono. So it's just 4 single channels, and then we got bass, and then we got high. So if we put them for 0 and 0, then it's more or less flat, the frequency response. But if I give it all the bass or all the high, it's gonna look a lot different. I will show you the curves from the manual, so you can see the frequency responses available by adjusting the bass or the high. There's also a built-in limiter. So now the limiter is off, or it can be turned on. Okay, it's a little bit difficult to operate. And we also got low frequency boost enabled possibilities on the first 2 channels. The first 2 channels, I think they are meant for microphones. They got high gain, and the next 2 channels, they got very much lower gain, so therefore line signals. It's also showing here little different symbols, A1, A2, or then probably a record player or something like that, right? But those are line levels or microphone levels, and you can of course change the sensitivity or make them lines levels by cranking down the 2 tiny pots here. They're just in series with those pots, so you can really select the range of all pots, so it's more or less the same kind of level you want, instead of having everything the first millimeter here, right? So it's of course a tube based. And this one is in a little bit of a sad condition. As you can see here, it's cracked. So somebody threw this in the container, I guess. And also, if we have a look through the cooling here, we'll see damaged tubes floating around. Oh yeah. See this little transformer here, this is a modification that was made for one of the inputs to make it completely isolated. And this is a normal modification to make on this unit. As you can see here, it can really suck through a lot of air. Look at all the holes, and they're also here on they go all the way through. See, this is my fingers on the bottom. And this is because this thing can actually deliver 35 watts into one speaker. So this unit was actually used to have a little mini concert, like 50, 40 people, and then 2 singers and a guitar, or I don't know. You can imagine a tiny little band having a tiny little party, maybe at a bar or something like that. Then this was definitely the unit you wanted. You only needed this tiny little unit. Because of its funny shape, it's also got a nickname, the toaster. So I don't know exactly why, but I don't have a toaster that looks like this, but... Or maybe it's because of this. It looks like you can put down bread, right? Yeah, I don't know. Maybe if you know why it's called a toaster, you can... Yeah. Maybe I should have a look and open this and see if I can carry on with this project. See, I'm now inside. Also, I want to show you, I'm starting to do a little bit of cleanup from the right side, so it's actually going to be pretty nice. And this is how it was, full of nasty old dirt and dust. It's fun to see the before and after at the same time, right? So now we're inside this amazing unit, and the input voltage selector is actually visible through a hole in the top, that hole. So you can read the input mains voltage through that hole, so that's really nice. But of course you need to open it, lift this and flip it to a new volt like that. So this is the mains input transformer, and there's actually a very tiny little picture here, but it says all about the different tubes. Where are they located? That is really nice. And it also shows something that I will try to explain on the schematic. Well, this is the output transformer, and this is the output amplifier. Let's look a little bit closer here on the output amplifier. The two EL36, they fell out of the sockets when somebody threw this. Yeah, I took this out and cleaned it. It's the EL6415, and then there is the EF86. Here is the input board, and that is a little bit interesting. If you see those tiny little sockets, they short the inputs to the next stage, or you can pull these out and plug in an amplifier module. So those are 3 and 4. That means, look here, 3 and 4. And this shows here, you can disconnect this little shorting device and plug in an amplifier module. In the 1 and 2, you can plug in signal transformers, and that is of course the amplifiers for the two A1 and A2 inputs. And I believe down here is the lamp for the light sensitive resistor, and that is creating the limiter. I think that is what they're trying to show here on the schematic. So you can open this and replace the bulb if the limiter is not working, because it needs light. The louder you play, the more light you get, and then it's attenuating the input, and that is how it is making the limitation. So look here, I mounted a DIN connector with the white and a shield for I think this is a microphone input, right? Going to the transformer, and that transformer is they just drill this hole and then put in this connector, and then this is actually more or less touching the pins on that connector. So that means they didn't really think a lot about what they were doing. That is a little bit stupid. So here's the case I would like to fix, but it's not just cracked, it's also bent. Compare it to the other side. I don't know if I'm able to fix that. I think I need to go and visit an expert, and then we'll see how that goes. So today is the day we're going to try and see if we can weld this case back together. We've been trying to push and bend and fix stuff, so the idea is we can push this back in and then weld it a little bit together, and that is kind of the idea. We're gonna see if that works. The first test, we're gonna see if we can melt this piece of material, because we're actually a little bit unsure about the material it consists of. So this is the first melt and check. Is that enough amps? Came home from the welding experiment, and I would definitely call this a total fiasco, a failure. And it's because this aluminium is not just aluminium, it's full of all sorts of funky components that just makes it impossible to weld. It kind of explodes more or less when it's melting, so you just can't weld this damn thing. But we got it sticky a little bit, just about right. So I'm now going to try and see if I can fix this with epoxy, and I think this is the strongest kind of epoxy I got. So yeah, let's try and do that. So the first little glue with super epoxy and sanding a little bit. Now I want to fill the little gaps down here with some of the more sanding, polishing type of epoxy that's much easier to sand. And then hopefully I can make this nice and shiny again and look exactly like the other side. I'm having quite a lot of fun polishing and adding tiny bits of epoxy here. As you can see, I am so close to be done with the epoxy and sanding. Just a tiny little bit of layer here, and then yeah, this edge here maybe needs a tiny little drop here. I really want to see if I can make it as nice and smooth as the left side. So I think I'm ready to play with a little bit of paint. I got a few of these, and I think I found a color that is very close to the right. I kind of got a little bit of a stash of these colors here, so I think I'll be able to either find the right one or mix the right one. I also did a last touch up with some more epoxy and some more sanding, so let's hope it's fine. This is the first paint job. I'm just doing it by hand. I was able to mix my own little blend, and like here I have one color and the other one, and the fun thing is the camera actually pick up the difference a lot better compared to what my eyes does. Maybe I'm a little bit colorblind. That's funny. But anyway, this is going to be pretty good, I guess. Let's look at the bottom of the unit. See, I'm missing two of the plastic rubber kind of feet. Look how tiny they are for this weight. That's not the best design for the feet. I would like them to be bigger. I was able to pull out a little piece of plastic here from one of them. So that means I should be able to 3D design or 3D print a substitute. It looks like I can remove this cover and gain access to the entire PCB here. And this is the back side of the input board. So that's quite smart. Look at all the air that can go through here, right? And that is the connector section. You can take out this entire piece of metal here and then perform service on it. And I think I also need to do that. I will show you why. So here's the connector section. I don't know, I'm not super duper happy about it. Look in here. This is the loudspeaker connector. I'm not even able to get some light in there. This is a really funny connector, and it also appears to be broken. And then we got the 4 inputs, and that looks like XLR, but it's like made inside this, so it's not that easy to redesign due to the distance between them. I can show you a picture about how my father modified one of these. I'll put in a picture right here so you can see how it could be done. I just don't know exactly how he would be able to fit all of them. Probably that was not the intention. Oh yeah, that hole is for another cable you can put in here and connect to remote control or a low voltage output. That is designed so you can kind of cascade 2 amplifiers. If you've got more amplifiers, you want more power, drive more speakers, then this line output here is the output. There's actually a separate winding on the output audio transformer that goes to this low voltage output. Here's the picture I found from my father's modification performed on a similar unit, and it looks like he replaced the 4 XLR connectors. So that is probably what I'm gonna do as well. And then the male is of course the output, because they were wrong. You know, it's female for input. That is not how it works. So we don't want to do that. Of course I need to change that. Of course I need to get the unit working first, and then this is definitely what I want to do. Aha, that is smart. I really like keeping those good old pictures so I can see what to do. Great. So this is the design of the feet. Of course they have been worn down a little bit, but they were definitely supposed to be a half square, right? And I got this little stick that was here sitting in the end of it, and I did some measurements, and after a few seconds of design I got this 3D model of the feet, of the little foot here, and now we'll try and 3D print it. So I'm just going to 3D print a few of those feet, and let's have a look. So those are 2 of my favorite 3D printers, my Creality printers. And yeah, it's only gonna take about 15 minutes for me to 3D print 2 new feet. Where are they going? Are they coming? Yep, yep. I make 2 at the same time. And of course I'm slicing them, lying down flat like this to make them as strong as possible, obviously. So now I'm ready to install my new feet. I just 3D printed those and fixed them a little bit. I sanded them a little bit flatter so they're not a half square but a little bit flat, because the original feet, they are now a little bit flat. See, I think mine is more or less the same. So now we'll try and see if I can push them in. So this is definitely how you do it. Easy. Oh, I got a little bit of progress. I cleaned it up and visually inspected everything, and here is the original tube that was still intact. As you can see here on the top, it has been running like 1,000,000 hours, right? So what I did is I called some of my friends and asked for some more tubes. And look at that. 3 brand new ones here. And those are from Telefunken. They look a lot different. But in the box, I also found 2 other boxes, Philips tubes. And look at that. Those are, of course, brand new in a box as well. And this proves this one was a Philips as well, because they are exactly like that. So I'm gonna plug in my new tubes and then see if there's any smoke. So let's try the first power on. I think I put the power switch for on, and here is my chassis to earth protection. Variable mains entry. Mains is now applied, and I will start from very slow and low. 60, 80, 90, 100. I don't see any filament. Yes, I see filament. This is 160. Let's turn off the light. Oh, look at this. This is beautiful. We are running at 220, as it is designed for 220. And I see all the lamps are glowing. At least those are glowing, and that is the most important. This is my output amplifier. This is the business end. 56 watts and rising fast. So that means I need to... No, okay, it's going down again. Pooh. It's always something that I need to look into. How about the amplifiers? Oh, I don't see. Are they? This is the input preamps. I don't see any light in those. That is a little bit interesting. The power lamp here is very, very nice. It's quite bright from the behind. I think I will try and put some signal through this. Yes, we got a light. Yes, also in this. Beautiful, beautiful. I turned down the light so I could see what I'm doing. But let me show you a very, very easy way to test this. This tube here is, of course, the microphone amplifier. Look at that. This one is nice and warm, and that will be the 2 line inputs, right? Ice cold. That can't be right. And here's the preamp for the audio amplifier. I don't know if you can see that. Well, that is the tube. It is ice cold. If you compare it to, okay, the ECC85 is very, very much different. And that one is, of course, a lot hotter. You can also see the filament inside that tube. It's very, very different with the EF86. And of course the output tubes, they are burning hot. 180. So that is completely expected. So yeah, I'll have to turn it off and figure out why I don't have any filaments. See, I took out one of the EF86 tubes. We got 3 of them in this. We got 4 of them in this unit, and the first one here is actually getting quite warm. So that is a little bit interesting. Why the other 2 they don't get warm, but this one, there's definitely filament is running, and it is really not getting warm, and it is also very, very hard to see the filament, and that is because of the internal shield. What you see here is not the anode. This is the shield. That one is the anode. See, now you don't see the filament because of the anode. And then the shield is connected to metal all the way around, including down here at the bottom. So this is a very nice way to make a very good audio tube that is not sensitive to noise and bad stuff. Nicely shielded. But this also prevents visual inspection of filaments, except you have to look through the hole. But if you're looking, see, into the hole at that perfect angle, then you don't see the filament again. So you need to look like that, right? And you need to know what you're looking at. Very dim filament. I don't know if you can hear the humming and noise. I put a speaker to the loudspeaker output, and this is the input to channel 4 via this little transformer, and my signal generator is now connected to very low input, and this is channel 4. Haha. If you hear the noise from the other channels, see, this is of course the high gain inputs, and that they will of course add noise. And now I don't have any noise. Oh shit, and bananas. Oh, I got a shock. That was funny. The damn thing can play really loud. Oh my goodness. Whew. So I'm still playing around with the back panel here and see if I can do a little bit of service on all this. So this is the loudspeaker output connector. That is actually one of those old style mains extension cords. And this one was pressed in between here, and then a screw went in here all the way through and into the nut that was broken off. So here was the nut part of it, and it was just pressed in here. That is a funny way to make an loudspeaker output connector, isn't it? That's quite funny. So this is the rear side of all the XLR inputs. I marked the different inputs, and that will be how it's done. So number 1 is green, and number 3 is white, and 2 is of course the shield, and then 2 is connected from 1, 2, 3, 4 and to the chassis. And here is the extra line input they made using an isolation transformer and this DIN connector. It's a little bit funny to see how the wires from this transformer here is wired to a little cable, and that cable goes all the way around and then soldered into the connector right here. That is really weird. Instead of just soldering those wires directly in here. I really don't like long, complicated wires on signal inputs, really. But I will now try and see if I can modify this. This is the screw that is used to mount the individual XLR connectors. So I think that is the way to disassemble this. So after a little while of playing around, I managed to figure this out. So here is the right connector, and that one fits now. I had to adjust a little bit in the connector to make it fit, and I also had to adjust in here to make it fit. And that is also because I wanted to put in a little plate so that when this is here, I'll be able to put in a plate and put in the screws through the plate and then screw that real good in here. And I was actually looking through all my boxes of goodies, and look what I found. I found only one, but that is definitely the correct XLR connector. The only problem is I only got this part of it. I don't have the outer part of it of this one, and I believe this one is a cable type of XLR, and because I don't have the cable part, that means I'm a little bit lost in finding the exact type, because it's not like those. This is a male one, but see, all the other female one, they got a little push thingy, and then they got this tab up here, while this one, the correct one, is looking a lot different. And I need this kind of edge around here, because that is what is used to align the connector in the holes. Toopity-toop, and then it works. And then I can put in the screw here, I can cut a thread, and then that screw will lock itself into that part down here. It's just almost too perfect to be true, but that is definitely what I need to do. But first I need to find some more of exactly this type, and that is where I am stuck a little bit right now. Well. Oh yeah. The holes in here, they were about 1 millimeter too small for the male part to go all the way to the bottom and create a good contact to the female part. So as you see here, I had to sand the holes, and I didn't have a tool to do that. So I had to make my own tool. You're not gonna believe what I did. I took a big bolt and glued some sandpaper, and then I made my own tool. Haha, easy peasy. Well, that's a little bit funny, by the way. It turns out the XLR connectors I need, they are very, very special. It's the 1960, 1970 model of this XLR connector, and that those are just completely impossible to find at the moment. Damn it, it's going to be difficult to proceed from here. You are not going to believe it, guys. I am in Jylland. Hehe. I am at Kronborg Elektroniks, and look what they got. 1 million really, really cool things. But what? Look at that. The missing connectors for the project. This is how friendly he is. So I went here with a brand new, and I'm gonna fix this, and I'm gonna get this, and then I can continue with my project. And by the way, if you need to have some really, really special and cool stuff repaired, fixed, upgraded, modified, please go to Kronborg Elektroniks, okay? See you. So now I'm back from Esbjerg, and look what I got. My 4 super vintage connectors, and I am super happy about that. Thank you very much for your help, Christian. And I am now ready to assemble this connector back panel. I had to do a little bit of tricks here with the loudspeaker connector. I had to cut it a little bit here on the edges, and I also had to make it a little bit shorter here around this the end. But let's try and see how this fits. See here, it can move, but let's hold it about in the middle. Let's look what I did on the inside. See here, I cut those pieces of metal away here, and then I made this little piece here in brass. Brass is super easy to work with, and I think this would fit like this, and then I hold it here in the middle, and then I put in my two screws. So I think I need to rotate it a little bit to get this distance better. I think if it's the other way around, I think it is a little bit better. There's some, see, this is how it was intended, and then just put in my screws, and see, now it's not gonna slide, it's gonna stay in the middle. That's what I'm gonna do. And then I can mount the other 4 connectors. I cut M3 threads here, so I can put in screws that will secure the connectors into that point here. So they just go like that, super easy. And I bet that is exactly what my father did, so I'm just copying in his design. But I think I made a little bit better solution for the loudspeaker connector. There's actually an important thing that just struck me. If we look at the setup here, the original was male, like pins sticking out, right? And they were mounted this way, okay? And the reason why I fool around with this is, of course, I want this to be connected correctly, all right? So I was looking at my original pictures when I took this unit apart. I, of course, took some really nice close-up pictures of how it was. And the green, the white, and chassis was mounted like this on the back side of the male. So that means it is completely wrong according to well, the standard that we do today. So here is how it was. As you can see, chassis was pin 2. And if you look at the correct way to do XLR connectors, pin 1 is chassis, 2 is positive, and 3 is the negative. So it's a balanced signal between 2 and 3, right? And this is how it is. And this is, of course, pin 1 chassis. So now I've put in female connectors, and now they are, of course, viewed from the back to cause maximum confusion. So again, 1, 2, and 3. So this is, of course, the current standard, and this is how I'm going to mount the cables. And here's my loudspeaker output. I am, of course, going to shield and chassis pin 1, and then between 2 and 3 I'll have my loudspeaker output. So that is how it's gonna be. See, I glued it a little bit as well, and I glued these, and then of course I put in my screws and also added glue and all that kind of stuff. So I think this is going to be really nice and good. It's actually a little funny thing about this connector panel. See, they made 2 holes this way and that way. So that means the back panel can be mounted down if you want this whole unit to go all the way back to some desktop setup or something where you want the cables to go down instead of back from the unit. So that is actually a funny way they've done that. It's also super easy for me now to put the module or this back panel like this, and then I can easily solder all my wires. Ha ha, nice. So this is the shield for the, this is actually the output tube. So there's a lot of gain in that one. So we got the 2 input amplifiers, and this is the output stage of all this, the input board, right? And there was, of course, this really nice shield here, and you need to be able to take this off so you can replace the tube. And it was super duper sticky, those 2 parts. The idea is you push it gentle, see, and this way you release it, and then you can rotate it and pull it out. But it was getting all loose and bendy. See, this is not good. And it is actually soldered to chassis. Here is chassis on one of those solder points here, and another one right there, and up here it's just a little piece of metal that goes through, and it's bent to keep it in place. So this is the input board, and here's the board with the compressor parts, and you gotta see this power supply rectifier is hidden down here. Isn't that funny? So it's easy to service. Nicely done with shielded cables. Interesting way to do that. So I think this video has already been way too long and super duper detailed, but I just wanted to show a little final. Now this unit is completely done and ready to be used and enjoyed. There's just only one tiny little detail, and maybe I'm gonna 3D print or design a new knob for this one, but we will see what the future brings. I'm not gonna bore you with any more of that. Maybe I'm also gonna go and find some other paint in exactly the right color and give it one last touch up or something like that. But anyway, so far I'm quite happy about the way that everything turned out. So thank you very much for watching. Hope to see you soon again. Bye bye.